Okay, ladies and gentlemen of calculus, we worked these problems out here just a bit ago. And I will show the key to the worked out problems. Technology failing me. There we go. Now we'll attempt to connect. There it is. So this is the answer key that shows these worked out. And here's number 7. Answer ends up being 28/3. 8's really easy if you recognize this function, the cube root function, being symmetrical like it is. This area below the x-axis cancels this area to the right above the x-axis, and then number 9. And now we come to number 10, which is a different type of problem because it's an absolute value problem. So that complicates things somewhat. But the way to do this is to find the zero of the function. So if you set this absolute value equal to 0, so we say x minus 2 is equal to 0. What is x equal to? X is equal to 2. So basically what you're looking at here is this. You can draw a little sketch of it. A little sketch right here. You're going from 0 to 3. And you have x equals 2 being the center point here. So you got x minus 2, you got absolute value of x minus 2. So you're right here at 2. So is this thing here ever going to be negative? No, it is not. And so what you have is this. You have x minus 2 right to here. And then you go like this. And so what areas are you talking about? You're talking about this area plus this area here. Pardon me? Okay. So what you had, the way it looked like originally, without the absolute value, it looked like this. It looked like this. But the absolute value of x minus 2 will rotate or reflect this area up here. And so this is one where you can work it out like this. You have to take the absolute value of this plus this. So you can write it as absolute value of 0 to 2. And you have x minus 2 dx. So you got to take the absolute value of this. So whatever this portion is here, you got to make it positive, right? And then plus, now this thing here, we don't have to positivize this because that's just going to be 2 to 3 x minus 2 dx. And so that's a strategy you can take on this type of problem. I think, to me, this type of problem might be about the hardest type of problem I have to deal with on these. That's just me. Okay? So I don't know how often you'll run into that, but if you do, that's how you handle it. Find your zero and just draw a sketch like that. You'll figure out what's going on. Okay? But using a calculator, you can do that pretty easily with a calculator, right? Because you can just make, do you know how to do the absolute value in the calculator?
Yes, abs. Abs.
Yeah, ABS. So you take this one, I'll show you that.
That's not bad.
So you go to, I like to go to second catalog, enter, and then you can go to math 9, and then you go to 0 to 3, and over here you put x minus 2, and then dx, and I think this will get it right here. Does that look right?
Oh, is that? How's it 1.5? There's no way, it's gotta be 2.5.
You think it's 2.5?
Yeah, because I put the absolute value like in the parentheses with the x minus 2
Yeah.
instead of on the outside.
Instead of on the outside? Let's see.
And whenever I did it off the graph, it was 2.5 whenever
So maybe I showed you the wrong way to do it. Here, let's do it again. Math 9.
And then I did the 0 to 3.
And 0 to 3.
And then the parentheses is when I put the absolute value.
Okay, then you go like this. You put x minus 2 in here. Oh yeah, that's right. This is why this is going to work. The other thing did not work.
2.5.
2.5, yeah, with the rounding error. Yeah, because this will take the whole thing. This will take the 1.5 net thing and make it positive. That's why that didn't work the way I did it earlier. And then what did you get for this one? Number 12, number 11. Did you do number 11?
No, we just did 10.
Do 10?
Together.
Okay, good. Yeah, do number 11 too. We'll see that. That looks like. The thing you have when you have pi over 2, it makes things easier with sine and cosine, because then you're talking about what numbers as answers for pi over 2. 1 or 0 or -1. 1, 0 or -1, because you're gonna get sine. So you go, yeah, sine. Sine is gonna be your integral of cosine. So this one here, you're gonna get, your answer is gonna be sine x from negative pi over 2 to pi over 2. And what is going to be sine of pi over 2? So you have sine over pi over 2, and you have minus sine
Sine of pi over 2 is 1.
of negative pi over 2. So here you have 1, and you minus, what's the sine of negative pi over 2?
1.
No, sine of negative pi over 2, that's
Oh,
negative
Negative
1. So what you have is 1 minus negative 1. You should get 2 for that. I hope that's right. So anyway, these are the ones that I think I'd worked these out earlier. I think that's right. I didn't work out 11 there, but there's 10 worked out. Yeah, so this one here,
No, it.
The way I did that earlier is I made this thing negative. So if you go back here, instead of putting absolute value there, what I did is I just made this area negative, since I noticed that would be the case.
So funny.
Let's see here.
Gee, I'm hurt.
Aaron just hit his head on the board trying to get his pencil.
I think I got it from concussion.
So you got to be in concussion protocol.
I think so.
He hit his head really hard.
I think I heard it. I heard it.
I love the concern, Mr. G.
Do you need a Band-Aid?
No, I don't. I don't think I'm bleeding.
Yeah, because that's the one thing I don't like.
Not from you. Not from him.
I don't like people bleeding to death in my classroom. That can ruin a day. People bleeding to death in my
Bleeding to
classroom.
death in your classroom? Have you ever had anybody bleed to death in your classroom?
No, I haven't.
That's a good.
And one reason that hasn't happened is because I have Band-Aids.
Aaron's gonna beat up the board. Aaron's gonna throw up on the board.
Okay.
No, not the board, just the border of the board.
All right, class, go ahead and do number 12.
Okay.
Work out number 12. What's going to be your integral of sine?
That's negative.
Or what's your integral of negative sine?
Cosine?
Will be positive cosine, right?
Yeah.
Yeah.
That'd be so funny.
Looks like we have this is the right hand at work right here.
Well,
Right-handed.
they're all bullying me, Mr. G. I really
Right
just
hand
want to
at
walk
work.
out. They all called me a really mean word.
We called her Mark.
No, they did. I don't want to lie to you, Mr. G. That's not what you called me.
Well, I think I have this on. I could go back as audio. I can listen.
They all three of them said it. I said it.
Maybe I'll say it. True Hannah. You're bad at me. I'll take it. Lunch, that's lunch to teach me that.
Okay. Let's see what we got here.
Hi.
Hi.
Who brought you?
Oh, brought me my dinner. Thank you.
What's $5? Thank you.
So Kyle, you need help something to make for dinner for people like me?
Yeah, next period, she's gonna make the lunch.
Very good. All right, so for this one here, number 12, I got x squared plus cosine x. Does that look right?
Yes.
And we're gonna go from 0 to pi. And now you plug in pi. So what we're gonna get here is pi squared. Does that look right? And then plus, what is cosine of pi? Somebody behind the math said -1, right? And then we're gonna subtract out 0 squared, which is 0, minus cosine 0, and cosine 0 is 1. So it looks like we're going to get pi squared minus 2. Does that look right? So that's going to be like 9, pi squared is like 9 point something minus 2. We should get 7 point something.
It's like 7.8,
You did it in the calculator?
yeah.
Okay, so
I
that-
can't remember if I solved it.
So that verifies it. Did you end up getting this answer too, though?
Yes.
Cool, good work. You guys are like some calculus students. Very good. So really, I think that's about as far as I want to take it today. Tomorrow what we're going to do, yeah, I think we're going to start on area between curves. Is that the next note card?
Yes.
Area between curves, we're going to do that tomorrow. And remember, homework assignment, right? For real, because you want your grade book to love you, right?
I remember starting it,
Yeah, so.
but I did on